Wow, there's so many people in here. All right, so as a machine learning engineer at Sleep Cycle, my main focus is working on audio-based sleep tracking. So just a quick hands up, how many of you guys work with audio? So like 4. How many work with like NLP and text? That's also like 4. Okay, what else do you do? All right. Anyway, so today I will talk about a project that we did last year, focused on how we identify the source of snoring in a room with multiple individuals. And I will also talk a little bit about snoring and why it's important to track your snoring. And this is also a collaboration with my 2 fantastic colleagues, Mikael van Holst and Mikkel Kogebek. They are also here today. I can see them here supporting. But they will also gladly answer any questions that you have after this talk. So remember their faces. All right, so what is snoring? So snoring is caused by the vibration of soft tissue in the upper airways, meaning the tongue and the back of the throat. And the presence of snoring indicates that the airway is encroached by the soft tissue, and this obstruction ranges from simple snoring to mild, moderate, and severe sleep apnea, where sleep apnea is when you stop and restart your breathing multiple times while you sleep. And unfortunately, a lot of people that suffer from sleep apnea don't know about it. According to apnea.org, about 80% of the moderate and severe cases in the US are undiagnosed, which is terrible because a failure to recognize this condition poses serious health issues such as stroke, diabetes, heart attacks, injuries, and death due to daytime sleepiness. All right, so that's sleep apnea. But what about like simple snoring? So I had to contact our sleep expert, Mike Radisar, to ask him, like, is there any health issues connected to snoring and not only to sleep apnea? And he gave me 3 interesting studies. The first one is a meta-study, meaning you do a study of all of the studies, on stroke and snoring. And they found that snorers has an increased risk of stroke with up to 46%. The second one is a massive Chinese study with about 500,000 participants, which was followed for about 10 years. And they showed a 12 to 14% increased risk of type 2 diabetes just by snoring. And then this last one, because there are some studies around snoring and cancer, most of them on lung cancer, but it's hard to know if it's the lung cancer causing the snoring or if it's the snoring actually causing the lung cancer. But this study, which studied sleep problems in a older cohort, so people over 65, found that snoring or snorers actually have an elevated risk of getting different kinds of cancers. And these are all serious health issues, which is why it's super important to monitor your snoring, to know how often do I snore, how much do I snore, what do my snoring sound like. And all of the contactless tools out there to track your snoring requires you to sleep alone. And we don't want that for our users. We want them to live a normal life, sleep in their bedroom with their pets and their partners and kids and whatever, but still get an accurate analysis of their snoring. So how can we do this? So first off, we need a lot of data. And as Sleep Cycle is the market-leading sleep solution app with over 2 billion analyzed nights and about 1 million daily active users, we're in a unique position to actually solve this. But we're also really concerned about privacy, and all of our audio models run on our user's device, meaning no audio ever leaves the user's phone unless the user actively shares it with us after listening to it themselves. So we are super grateful for all of the users that actually share their data with us. Otherwise, we couldn't be able to do this. So for this project, we used over 2 million audio clips that we knew had snoring in them from about 500,000 users in around 150 countries. So we have large amount of data, which is also diverse in a sense that it's different sleeping environments, different pets, different cultural sleeping situations. Because if we're going to do this, it's going to work for everyone, everywhere, no matter how or where you sleep, right? So we thought about it for a while, and we quickly realized that a supervised, like the traditional supervised model, won't really work here. So we tried a different approach, which then ended up in a few-shot learning method. And for those of you who don't know what few-shot learning is, I tried looking up like the real definition. I couldn't find one, so I will give you my own. So basically, it's when you have a really small labeled data set, hence the few-shot, and you use that together with a large model, which is trained on a lot of data, to solve a new task. And this will probably be a bit clearer after you see what we did. All right. So we want to know who's snoring in a room with multiple people. So let's break this down. First off, we need to detect if anyone is snoring, right? We got to find the snoring in the room. Then we need to create an embedding network that can accurately separate people. So snores from the same individual should lie closer together in this embedding space, and snores from different individuals should lie further apart, right? And then, as we probably get some clustering from these snore embeddings, we ship the model to the user's device. We ask the user for some labeled snores, hence our little data set. And then we train a k-nearest neighbor model to attribute all of the snore as either the user or someone else. All right. So first step, detecting the snoring. This was pretty fast for us because we already have this. We have a good high accuracy audio event detection model already running in production on our users' devices. And this was developed by Mikael Kågebäck, and I will only give like a brief overview of how it works. So basically, the standard way when you work with audio is that you take the audio and you transform it to its spectrogram. And you do that by applying the Fourier transform to successive frames of the signal, and then visualizing the resulting power spectrum as a function of time and frequency. Then you get this nice image that you see. And this is actually a 10-second audio clip that has 2 snores in it, and you can see it here. This is where the frequencies fire up. So we take the spectrogram, we run it through our convolutional recurrent neural network, which is trained on millions of audio recordings. And it's a multi-label system. So for each time segment, we get a probability that the time segment has this label, or all of the labels. And this is trained on 10 plus labels, and some of which are breathing, movement, sleep talking, and also snoring, which is what we are after. Okay. So this will then output a probability for each time segment, and we can use those probabilities to find the snoring events. So we have a start and a stop of each snore in this audio. So that's done, right? Now we just need an embedding network to separate the snores. And we tried to use the embedding from our audio event detection model, but unfortunately we didn't have enough signal to separate individuals. It's awesome at detecting snoring, but not to actually separate on people. So we had to do something else and train a new model. And fortunately, this is really similar to an already solved problem, which is face recognition. You know, every time you look at your phone, it needs to verify it's you staring at it before unlocking. So we found this paper, which is FaceNet, which was created by Schoff et al. In 2015. And what they did was they trained a deep convolutional neural network using something called a triplet loss. And the triplet loss here is the key to the whole thing. So what the triplet loss does is that you take your data sample, which we here call the anchor, and you also choose a positive sample, which is from the same individual, and a negative sample, which is from a different individual. And what you want to do is that you want to move the positive closer to the anchor and the negative further away with at least some distance. Okay. So this will help us to actually separate on individuals. So now our system looks something like this. We got our audio, we convert it to a spectrogram, we run it through our convolutional recurrent neural network, we get our snore embeddings, and then we take those, we get our snoring events, we cut out the snoring from the spectrogram, and then we train our CNN on separating different individuals. And during the training, we also know an anonymous user ID for each snore. All right. So we get something like this for a night with 2 people sleeping. And here you can see the clock. We fast forward the night, and each dot here represents a snore or a snore embedding. We use principal component analysis just so that we can visualize it in 3 dimensions. And the line that you see is a line that we draw from the current snore to the next. So we can actually see that there are 2 people snoring interchangeably. Nice. That's done, right? Now we just ship the model to production. We need an interface. This was built by Mikkel Holst. And as you can see, we detect all of the snorings. And then we also have a pop-up if you listen to the snore, and you can annotate if it's you or if it's someone else or if you don't know. Because sometimes you don't know. And so for each snore embedding, or for each snore, we create a snore embedding. So if these dots represent the snore embeddings from the night, the user says, okay, this is me, this is also me, this is my dog, these are my partner, maybe. And then we can use those by a simple k-nearest neighbor to attribute all of the snores as either the user or someone else. And then, of course, also update the snore statistics. All right. So that seems like a good solution. The whole network now looks like this. So again, we have the audio. We create the spectrogram. We find the snores. We feed it to our convolutional neural network. We get the snore embeddings out. The snore embeddings are then inputted to the k-nearest neighbor together with a few randomly labeled samples from our user. And then we can attribute all of the snores as either user or not user. All right, so now when you actually can see your snore pattern, you know if it's you snoring, you know how much you snore. You can actually hear some of your snorings. You can also see if you have any health issues, right? You can take your audio to the doctor and say, hey, listen to this, I don't know if this is healthy. Or just keep track of it, which is great. But we're not really done yet. So you get accurate statistics. But from that, we can also use it to detect the risk of sleep apnea. As so many goes undiagnosed, we want to help people, right? We are also currently building an aid to help you reduce your snoring, which we are validating currently, so hopefully out soon. And then we're also doing a lot of studies. Currently, we're doing a study together with Cambridge University on sleep pattern and Alzheimer's, which also uses this updated snoring technology, which we are super excited about. So, yeah, me and my colleagues, we will be here all day. So just come and talk to us if you want to know more about us or the solution, or if you want to do any collaborations. Thank you.
Thank you. Okay, so a few comments.
Yeah.
No, but on the slide with the risk of snoring,
Mm-hmm.
you used words like up to 76% and then elevated risk of cancer and so on.
Yeah.
And those are classical like ways of thinking, making people think that the risk is higher than it actually is, right? It's not quantified enough. So can you actually quantify those risks?
I'm not sure.
So if you think that snoring is dangerous now, you should go back and look at the actual numbers.
Yeah, you can read the papers, because the papers are linked there as well. But since I'm not like a medical doctor, I just ask the people that know stuff,
Right.
and then, you know.
Cool. So I had another question actually. So the first, I mean, I love the talk since you can hear the words like snore embedding. I never thought I would do that, but it's a nice term. So how is the annotation done in the beginning? Like you said that you did this triplet loss,
Yeah.
and you take a positive example and a negative example and an anchor. So how do you know that you have an actual negative example, and how do you know that you have a positive example without having the annotation from the beginning?
So all of the audio recordings that our users are sharing with us comes with a user ID, which is anonymous. But we still have an ID, so we know it's from the same user. And then we can pick samples such that we compare your snore with my snore. So we take 2 from you and 1 from me. And then we do that for the whole batch, or all of the examples, basically.
Okay, but in the positive case, you might actually have 2 people sleeping in the same room on the same user ID.
Yes.
Okay, so you're not sure that the positives are actually positives?
No, but due to the large amount of data that we have, it generalizes anyway to different people.
Mm-hmm. So have you tried listening to people that snore at the same time?
Yeah, I've tried. And it's kind of hard to know who it is, of course. But, I mean, it will attribute to one of them, depending on the distance to the clusters. So usually the one lying closer to the microphone, because usually most people, when they go to bed, they take their phone, they start sleep cycle, and they put it on their nightstand. And then you have your partner on the other side, which means your sounds are going to be picked up with a higher volume than the other guy.
Okay. Cool. Do we have any questions from the audience? Yeah, one over there.
Thank you so much for your interesting presentation. I just have a question regarding, do you have any, humans are humans, we have sleep cycle, and then, oh, I snore so bad, my life is crap, tomorrow I'll die. That kind of a mentality. Are there any ways to mitigate using maybe policymakers or taking this into the general healthcare or stuff like that?
I'm not sure I understand the question, but I mean, if you see that you snore a lot and you listen to your snoring sounds, then you can always seek medical health and just, hey, should I be concerned or not?
Yeah, but maybe it works in other countries, but I know in Sweden, healthcare providers are not, they have very clear policies that they should not work with applications. They are very skeptical to those kind of stuff, like smartwatches and so on. So I'm just thinking from that perspective.
Okay, that's really outside of my area, but I think if you can find people that actually want to use smartwatches and such. I have a friend who went to the dentist, and he was super excited that we were working with teeth grinding. So I think you need to find the right person.
Usually you want these applications to be regulatory approved as a diagnostic tools.
Yeah.
And that's what they are skeptical about. So maybe Sleep Cycle can try and go to the government or whatever agency that is responsible for that and see if it can be used as a diagnostic tool. I guess you're thinking about that maybe. Any other question? Let's go there.
Thank you for an interesting talk. I am more curious about how you separated the samples. So the person up on the stage here, he asked, okay, so how did you find out how they were different persons to begin with? I am more concerned about the annotations that the users did, and they would say, oh, that's not me. Maybe to game the system and get a lower score or something.
Of course, you can do that.
But maybe with all the data you have, you can figure out, oh, well, that is really you.
Yeah, I mean, if you want, because people actually use these snoring scores on Tinder now. So if you want to do that, you just say, it's not me, it's not me, it's not me, it's not me. It's going to show you 0 minutes, right? However, maybe we could, but since no audio ever leaves your phone unless everyone shares it with us, we can't really tell you, yeah, this is you lied, even if we wanted to.
This is probably going to be a difficulty if you're trying to get that tool approved as a diagnostic.
Yeah, I think so.
Okay, let's go there maybe.
Hi. How similar is one person's snoring across time? Like, is it is it similar, or can it be detected as two different people at two different times? And what's the time scale for variations in snoring patterns?
So your snoring varies depending mostly on how you lie, like your position in bed. So if you lie on your back, you snore usually louder because all of the soft tissue falling back. But since we randomly sample snorings during the night, and you can also annotate from different days and so on, you actually get a few samples from each, but they're still kind of similar.
Does that mean that one person has to label a couple of different cases before you can use it, so that you cover all the different situations for one given, or the characteristics of one person's?
So usually we need about 5 snore samples to actually do the clustering.
Yeah, thank you.
Okay, maybe one last question, if we have one. I don't know which one was first. Yeah, okay, take the man over there.
Hi, yeah, thank you very much for a wonderful presentation. I was just thinking, for example, when you go forward, in predicting, if people have a issue when they have with their snoring, is I'm just thinking you're going to have more types of data on the person, because surely you can't detect with just one person with like bad snoring that they could be a really healthy person, for example. Like what other sort of data are you going to take into consideration, like to predict these things in the future, and how are you going to do that? Or do you do that in the app already? Like, for example, if you're going to take like blood pressure or weight, for example, into the consideration.
Well, so the question is, how do we detect if someone is healthy or not, basically, in the future? And I think we use the data, all the data that we have. So if you connect your Apple Watch, we also get like pulse and the saturation, blood saturation, and all these different vital parameters. We will of course use that. Also your regularity. I know that like for some Alzheimer's studies, you also look at your like walking pattern if you start behaving differently. So everything, all the data that we have that the users want to share with us, I would say.
Okay, thank you, Maria.
Thank you.